Okay, just a quick introduction. This is not a how-to video. This is not an instructional. Just to give a bit of background, I bought a motorcycle KZ440C several years ago. You can see some videos of that on which I've made earlier, and it had a lot of issues with it, mostly electrical. Wiring was a complete mess. It's just patched together bits of insulating tape, but also it just felt really unstable. Yes, we used a very standard Kawasaki frame, something like this, like a like the B1, or in fact, if I get the exact model, it's like this, and it's pretty unstable. So Kawasaki used these frames, this sort of type of frame design, this pattern in the 1970s for two-stroke motorcycles, and anything above 60 miles per hour starts to feel really unsafe, But the engine itself was pretty good. It was robust. Now, I managed to get that working with a 2-into-1. It was somebody's abandoned project, and it took a little while, but it was running nicely. So I just kept the bike. Didn't really do any sort of restoration work on it. Just made it spruced up a little, and that's it. So what happened was earlier, a couple of months ago, as by the time making this video, the engine blew up. I have a habit of redlining every bike that I've got, all the time, almost, and it just gave out quite suddenly. So working fine, then just gave out. So I use a pretty old engine. The mileage recorded was 57,000 when I got it. So it's probably been around the clock, and I put perhaps 4,000 miles on it during my ownership. So that particular bike was pretty much knackered. So I even though it's strictly sort of kind of grey area, but I imported a frame from America. I'm very fortunate to have one for £40. It is in this style, which is very unfashionable. The main difference between these frames is, apart from the styling, is it looks different, but this frame is actually designed for this engine. So this one uses a number of spacers, very generic spacers, to fit the engine into the frame. So that's a multi-purpose Kawasaki frame, and this one is for this particular engine. So I built a bike around that using the parts that I had and a couple which I had to buy. So I did that pretty minimally. I didn't even want to buy side panels. So I managed to find a front mudguard, even though they're very expensive. I didn't really use all original parts. I made sure it's good, the electrical system and everything else. So it was at that time that it blew up. So it's actually this one, not that one, as I said earlier, which time the engine blew up. So I brought this bike home, limped it home, just sudden loss of power when I was redlining it, and I did a basic compression test to look for symptoms, and there was no compression. Well, hardly any. I think it read 60 on the left and 150, which is okay. My gauge may be slightly off, but there's a big difference there. So just using the difference, I knew that it had to come apart no matter what. So there's all sorts of things you can use, endoscope and leak down tests and everything. But bottom line is, if you've got a problem like that, you have to pull it apart. So so at the time of making this video, yes, I've completed everything, but I just need an introduction stage to set some background. Additionally, this engine was, I thought it was untouched, but in fact, as you'll see in this video, somebody had been through it at least once. Foreign objects and all kinds of strange things about that engine. Yeah, so that sets the background. I've put it all together, and it's working and it's fine. Yeah, so the main reason this isn't an instructional or how-to is because I'm holding a phone in one hand. I'm not demonstrating anything. I'm not teaching anything, especially. It's quite important to make that point, because in this manual, it states everything that you need to do. And so there are many things which I did sort of strictly you shouldn't really do, but never mind. For example, you should use an engine stand. You should use plastic gauge to measure various things inside the engine, the crank, the clearances and everything like that. I don't have plastic gauge, and don't have a dial meter, and there are also other things. There are many things to measure, absolutely everything, even down to the clearance of the oil pump and the twist in the crank shaft. So because I knew the engine was basically good, apart from the issue which you'll see, which is blown piston. Apart from that, I knew that the rest of the engine was basically good. So I just checked that it was within spec using using my gauges, and it was within specs. So things that I could renew due to availability of parts, I did renew. And yeah, so this is the video. Okay, initial inspection, and there are no metal fragments or anything like that in here. So they're probably all behind the oil strainer. This is clean. Nothing in here, no bits. So I've drained off the oil. So the fragments didn't quite make it this far. Okay, I was in fact wrong. There is quite a bit of fine silt down there. Now, some of this came from the outside, the external part of the oil filter housing, but some of this, I think, was actually caught by the oil filter. Okay, just to note quickly a couple of issues that arose when removing these the side part here. I broke off this part accidentally while trying to remove the this bolt, which attaches the advanced timing unit, and so I'm going to replace that. So this is a positioning pin, so the ATU is in the right place when the engine's at top dead center. It just locks in that place, you never have to fool around with it. So unfortunately, to remove this bolt, I had to file it down. So this is originally a 13mm bolt, and I filed it down to 12. So it's probably going to stay like that, no reason to replace it. The reason this happens is because this engine rotates the counterclockwise direction, and this was over tightened, so unfortunately I rounded this off, and so I had to file this down. Another thing, to split these cases, I have to remove this external shift mechanism. I had to cut little slots in these screws here. It's just so tight. But apart from that, it was pretty straightforward. And something I did notice as well as this. Right, so while I have the engine out here, and you can see everything quite clearly, just to illustrate something which I've observed, you can just about hear a slight knock. Whether that's excessive inflow, play, or whatever, I'll only know when that's opened up. Additionally, just to point out, because it's stated on some websites that you can't actually replace this push rod clutch seal without splitting the cases. Now that's untrue, so I've put this one in. It's an OEM seal, it's really nice. So compared with what it's sometimes replaced with, this is a far superior design, which radiates force outwards, and it has a little lip here, so it completely seals around the outside. So this is only covered in dirt because I've been flushing this out with petrol to clean it. But that's a pretty good thing. If you can get an OEM clutch push rod seal, you can replace that pretty easily. So yeah, as for the metal parts which may be lost inside this engine, I know I've just dropped a huge bolt down here, but still you can't see it. That's because there's a huge capacity for things to get lost down here. So this is something I'll only know when it's opened up. Oh, what's that down there? Just a little bit of dirt, whatever, I hope. So yeah, so moving on to splitting the cases. Moving to the underside of the engine, the oil drain hole here requires helicoil, unfortunately. I managed to get these screws out using the same old method. And here we can see the lower crankcase half removed. And it's a good thing that we did remove it, because yeah, there's a lot of stuff there that's caked on. That actually feels like pieces of sludge mixed with bits of metal and everything. So that oil sieve caught a lot, and it protected the oil pump. But that doesn't necessarily mean no bits got into the engine, or because the first port of call was the crankshaft itself when those pieces of metal fell in. Unfortunately, it is a bit gritty. Just a short note to say I found that there is in fact some grit inside the oil pump. This spins nicely when it isn't assembled, but there are some pieces that have got past the oil filter at various stages, so I'm going to have to sort those out. And just for a close-up view, this is how caked on it is. Really disgusting. Kinds of metal and bits and pieces in there. It's definitely metal, ground up pieces of aluminium. Wow. So nothing would have got through there once this thing happened. I do notice there are all these bits of red rubber sealant. I didn't put them there, but I think there's a strong possibility it may have contributed to some kind of problem. I'm finding so much of it in the engine. Here is the crankshaft, and I don't actually know what this is. There's something in there, quite a few bits and pieces, bits of sealant and stuff that got inside. So one of the possibilities that I've been thinking about is an oil passage leak having caused the oil passage blockage having caused the overheating condition on this bike. But these are all things that can now be sorted out. As you can see, there are bits of rubber in here. And upon initial inspection, when we see this balancer mechanism, the con rods are pulled right down, so that's at top dead center theoretically. It feels a bit loose, but these counterbalances are in the right position, both level half moons, as is what I'd expect here. So I'll have to remove this and check the wear here. With regard to the gearbox mechanism, I wasn't really expecting to find any play, but I think that is probably over 0.05 millimeters. I'll check that as well. This is the 0.05 is the maximum allowed for the end-to-end play. Actually, might be all right. I don't know. Yeah. So these are all things to move on to. Okay, I was expecting to get a little further here, but I've found so many pieces of piston ring. It's really quite interesting. They all seem to be in this in the gears, and as you can see, there's even a piece here, really sharp and nasty. I don't know how they got to all these different places, but obviously at speed, this is not something that is desirable. Okay, so move on. Basic wear measurements and clearances. This is a 0.4 millimeter gauge. So with this pushed all the way out here, that's absolutely fine. I can't even get that in. So the limit here is 0.45. Now, contrary to what I stated earlier, first gear, second gear clearances allowed, maximum 0.5 millimeter. There's no chance I can get that in. And if you look really closely, you can see someone else is taking care of that by inserting the 0.5 millimeter washer, which is the correct method. In fact, there might even be two of them. Okay, so that's a nice gearbox. Additionally, side to side here, I'm allowed to have 0.5 up here, just here, on each of these, and there's absolutely no chance of getting a 0.4. So I'm really happy with that. So yeah, this has been mostly cleared up now, cleaned up. My method is just to use petrol at this stage. I mean, just to remove bits of dirt and whatever, and then immediately I'll cover it with gear oil, prevent corrosion. So if I remove this thing, so this is an end cap which houses the balancer mechanism, and the crankcase, both lower and upper, and this end cap are machined together, so they wear together. It means in theory, if you have excessive wear, you have to replace the entire set, lower and upper crankcase halves, and this end cap. If I remove this, demonstrate something else. So yeah, there are many things you can measure. I don't have a dial gauge. I do have feeler gauges. I've got a micrometer as well. Just from the look of things so far, it seems to be pretty good. Important thing to note with these engines, they say let's look at the markings, the measurements and wear. As you can see here, this is where the wear occurs. So this is integral, this is important. This side to side here is loads of it. So what I was measuring was this. This is looking pretty good. And with the crank removed, we can see where damage has occurred, and there's quite a few little chips, sharp bits here in the crankcase. Obviously it's very usable. You can see extreme, well, high velocity has really scratched this up. So that's occurred on the bottom half as well. These sharp little bits here are not casting marks. That's damage caused by pieces of piston rig. Okay, now that the upper half of the crankcase has been cleaned up a little, I can examine and see the condition of some of the things that I wish to replace. So I've blasted through these with jet pressure water, plus soapy water as well, just to get the oil passages through to the other side, and this one as well, so this flows nicely through. Yeah, so I need a new seal. All these seals will be removed anyway, or will be changed. What I've found interesting is the situation with regard to these crank bearings. Interestingly, 3 sizes are supplied, or were supplied: brown, black and blue. So the ones that are fitted are of indeterminate colour, but you can figure out which ones they are. They are in fact black and blue, by reference to the marks on the crankcase and also to marks on the crank journals themselves. So I'll probably throw up a picture of that right now. So yeah, it's black and blue, and unfortunately they aren't available anymore, so it doesn't really feel like a proper rebuild without those. But I'm going to go ahead anyway, because the ones that I've got are actually fine, they're not damaged at all. But I really would have liked to be able to obtain those. So currently, as I make this video, there's a full set of brown ones, which is the smallest size, which is no good to me, on eBay. And so yeah, it's the same sort of situation with the big end bearings as well: brown, black, blue. Yeah, so I'll just go with what I've got. I'll change the cam chain anyway. Okay, on the right here is the cylinder head which I intend to use. Actually, the original one for this bike, and it's not perfect, but the valves are good. There's faults with it. It's got this new bolt. It's retapped. It's a bit thicker, and this has a helical. It's been drilled out. It's helical. Otherwise, it's fine. So I've got to clear that up, clean all this up, remove the spark plugs, which are no good, and fit new valve seals. You can see the one that was damaged here, which I'm not going to use. Okay, it's a quick change of mind here. Here's my old cylinder head, the original cylinder head one which was damaged. I've just been going around this with a rotary tool. I think I might just be able to get away with reusing it, because it fits within the circle. So it all hinges on whether these tiny little pieces, these fragments, are just stuck inside, whether I can get them out. I'd like to reuse this if possible, rather than use the original cylinder head, if that makes sense. Now reached a point where the cylinder head has been cleared up and the chips and marks have been ground out. So I'm hopeful that this will work. Okay, I've changed my mind several times during this process. I've decided to go with the damaged head and reuse that. So what I've done here is I've gouged out the marks from the damaged side. I can't actually remember which one it was. Just from looking at it, it was this one. Okay, So yeah, I've removed the gouges and everything, and then I had to measure the amount of water it would take roughly to equalize these. So use a cup of water with masking tape on the side marked upper and lower levels, and I'll try to get these roughly equal. So when this was on the bike, when it was in the failed state with one piston blown, the good side, which is this side, measured 160 psi on my gauge, and the bad one measured 60 psi. So that's probably just held, whatever psi was there was just bits of carbon which were holding it sealed. So removing material not only necessitates equalizing the volumes inside these domes, but also because it actually reduces the compression, I had to bring it back up again. So this method never fails for me. I just use a piece of glass here with sandpaper on top of it. So 80 grit, just keep going, and down to 20 grit to illustrate that it has actually gone down a bit. Use the old gasket here to match these holes up. And you can see this one would actually seal, so the holes are matched, I think. Yep. So that would seal, and obviously this one would as well. So I've got to do this again. I've got to measure the volumes again, having skimmed this head, and remove material as necessary to equalize the volumes in each dome. But otherwise, that's fine. Yeah. So I have actually broken a piece of glass before, so I back it up with this MDF here before going at it, and just not leaning on it but just sliding it along, and this does seem to work. Okay, here are the old pistons, and here we can see exactly what the fault was which caused the major failure. So here you can see there's a little piece blown out, this little, and this is the main issue that occurred. So my best guess is that there was a seizure, and following that seizure, the force produced by the other piston, which hadn't seized, forced this piston with broken rings to continue moving inside the barrels. Now this is where you can see all of the rings except the oil rings have been removed, except for one little piece here that's stuck inside. So this would have been projecting outside on the opposite side and tilting the piston, causing it to lock up. So when it reached the top of the chamber, you can see there pieces of piston broke off, and damage has been caused. Pieces of metal have been lodged in there, as well as in the cylinder head. Now it looks as if this was bound to occur because the other piston has the same sort of damage just beginning to occur. This is the other piston. You can see at the top there a couple of nicks and marks. This is where the end gaps of the uppermost ring would have been sticking out. But otherwise these rings came out fairly easily. See the oil ring still there, and it's absolutely fine. You can see damage to the piston ball just the same as the other piston. The cylinders have returned from the engineering shop. This is the original, and this is a replacement set I had to get. As you can see here, there's a huge nick. Didn't clear up. Yeah, it's that one. Didn't clear up, so I can actually feel that with my finger. So this was a failed attempt to rebore. This one is perfect. I had the measurements for the standard size when I purchased this. I actually imported this from Spain. So these currently will fit these 0.5 oversize pistons which I have here. So it'll be just like brand new, really. You can see how brilliant it is vapor blasting. It's just so perfectly clean. So yeah, I'm out here in the rain simply because I prefer it. There's more light out here, even though it isn't ideal and it's probably rusting as I speak. So I'll put a bit of film of oil on this and continue. Quick video on this one. We have the original front cam chain guide. You can see the amount of wear on it. So this is scrap. It'll be replaced along with the cam chain itself. And just something to note on this is a very rare part, and people are throwing these away. It's fairly typical actually for Japanese bikes. So I had to import this from America. This is new old stock. So it actually seems like hard plastic, really hard plastic, and it's all worn out, but it isn't hard plastic. Actually soft. You can depress that with your finger. Fairly soft. And that's old. So it's new old stock. So it's not ideal. So it's always a compromise. You can see the bits flaking off and everything. It's probably a lot of Japanese bikes have this kind of issue. If you have a different design, you don't really have that much parts availability as time goes on, and they're just basically disposable. So, you know, as necessary. So from the crank, I've removed this broken piece of positioning spindle for the timing unit. Same method you would use for engine side seal. You wind a screw in, pull it out. So I've got a new old stock one here. £3 delivered, so it's rare for something to be that cheap. But yeah, it just saves you from making a new one. It's just a piece of spring steel. It's in there. Okay, so at the moment, I've fitted the new pistons, and they have the gudgeons and circlips all inserted there. They're all ready. So these are simply the orientation shown by an arrow. So I'm facing the bike. The bike is going that way. So yeah, that's good. And my method for putting these on was simply to use a gas cooker stove, plus put the gudgeon pins in the freezer, and they come on really easily without overheating. Good. So when I originally obtained this bike with my previous bike with this engine, it was really difficult to remove the oil filter. So no matter what I did, the bolt just wouldn't move. It didn't round off or anything. It was just it was just absolutely solid in there. So what I ended up having to do after trying various things was cutting a little slot inside it, and badly from the side, welded in this piece of square section steel. It was actually longer. So I got a really long lever on that and extracted it. It's about 1.5 meters long until that lever squeaked a lot. I got it out. But just to note, because I intend to replace it with this pattern part, which apparently fits a lot of Japanese bikes. You can see the difference here. This is a very robust piece of steel with fewer holes in it than this one. This actually has slightly more flow. Okay, just moving on to the surface preparation and painting of the individual engine parts. This is probably going to be my only section of the video on this, just to say this is not the proper way to do it. The proper way is vapor blasting, in case you want to do that. But what I've done here is just brush it down, soften it up with toothbrush and some petrol, and scrubbing it up using some rotary tools as well, and then flushing it all off with pressure washer. So I intend to use this. This is engine enamel paint. Apparently doesn't need any kind of priming. So most of the dirt is off, but it's not completely spotless or anything. This is a basic method I'm going to use just to freshen up the looks of this engine a little. Lower half crankcase done. It has a new oil filter seal. I need to replace these bolts. I need to get new ones. I damaged the old ones getting them out. This also has oil pump fitted now and new gear shift seal. Just about to see. So ready to mount, then gear shifter mechanism. To inclement weather, I've moved the rebuild indoors, just inside the garage here, and I've replaced most of these seals, oil seals, crank seal, output shaft seal. This was already new, this clutch push rod seal. This end cap is the original one. It's the only really tricky, well, not that tricky, it was installing this balancer mechanism. I found the process, initially I got it wrong. You just set each wheel to a marked point colored plate on this chain here. So when they're balanced up, you can set a middle tooth, which is also marked. Set the middle chain link to the crankshaft. So that's the top half, and I'll move on to the lower half. Before I proceed, I'd like to show some of the things I've been using and some of the things I intend to use in this build. So generally within the engine, general purpose grease, assembly lube, semi-thin synthetic, quite sticky, but also will disappear in the oil, which is quite handy. Semi-setting gasket sealant. This is Hylamar Blue. To join the crankcase halves, 3 bonds, 1184, just because that's what I've got. And there's only for one use really, which is a little piece of rubber to seal part of the alternator, part of the cable going from the alternator to the rectifier. Also normal general purpose bed cycle oil 10W40, which should also be the oil going into the engine. Quick progress update. Starter motors in, gear shifter mechanism in, everything torqued down, 2 halves are together. Yeah, this is, I actually forgot to put the gasket in for the oil pumps. I've done that. It's pretty straightforward. Tested the gears, they work fine. Then in the process of rebuilding this, I made a couple of silly mistakes. I got the cam chain tangled up at the bottom of the engine case, stuck everything up. That happened while I was actually attempting to put the cylinders on. So unfortunately I had to split it all again and do the whole thing again. But in a way I was lucky I did, because I noticed that the pistons were in the wrong way. So I've sorted out that issue now. Additionally, the clutch and primary drive have gone on. So what remains is to put this gasket on and clutch cover, side cover of the engine. Other than that, fairly sure this is all okay. So clean off the remains of this Hylamar Blue and continue. Clutch side cover and automatic timing unit are now in, and the piston set up top dead center. It's pretty good, pretty uneventful. As you can see, I've filed down this bolt, and that's what I'm going to use. There's originally 13mm bolt head. It's gone down to 12. Okay, I put this together for the second time running with a new second base gasket. So luckily this time didn't tangle up this cam chain, and this is about as far as I'm going to build before putting it on the bike, because it's getting heavy. So on to the next stage. Okay, engine's in the frame and the bike is being pieced back together. But I just thought I'd show this. This is something that broke. This is an oil breather, which directs oil pressure from the crankshaft up through a passage in the camshaft cover and pumps it out. So this actually broke, the original one broke, so I imported this from Spain. Just to note that, it's quite interesting, another rare part. So now the engine is assembled and roughly things are put in place except the fueling system. I want to check for the first time post-assembly that I have got compression roughly in each cylinder, just to check I haven't made any serious mistakes. So in this case, there is grease and oil inside the cylinder, so it may read slightly higher, slightly lower because it's cold. Just as long as it's in the right ballpark, I'll be happy with that. So this is the right cylinder. Just hit the starter. Okay, so this isn't the most accurate gauge. Nevertheless, that is actually fine. So it's the right size, right side cylinder. Yes. And now for the left-hand side compression test. Spot on, that's what I want. Good. I'm tired of boring videos myself, don't want to subject anyone else to them, but all the adjustments and settings have been done and the bike has been reassembled, ignition done, valve timing done, everything done. So here's the moment of truth. It's cold exhaust, cold engine, fuel switched on, ignition on.